Welcome to the video overview for Team J submission for Assignment 2 CA675 Cloud Technologies. For our Cloud Technologies project, we have obtained a dataset of roughly 1 million songs. You can see here that we have obtained the training test from this website, which contains about 850,000 records. Each record is a song. We have the artist, similar songs, the tags assigned to that particular song, and the track and title. With this data, we've constructed a directed acyclic graph using the Spark framework and Graph Frames and GraphX packages. We have leveraged machine learning and graph-based algorithms to calculate various network statistics, and we have used these statistics to style our visualizations. You can see an example of our visualizations here. This is 2D, and we have also created a 3D virtual reality enabled graph. More on the visualizations later. First, let's have a quick look at the tools and methodologies used to construct our final dataset for visualization. To do this, let's step over to the code. So first we have a couple of bash commands for merging the data and pre-processing before loading into Spark. We also, at the bottom here, have our AWS configuration and our command to connect to our master node and start the Spark shell. Get to our graph processing. We create our edges and our vertices data frames, which are necessary to create the graph object, or in this case, the graph frame object. For AWS or a machine with a lot of memory, it's important that you would cache these data frames as they are the underlying data structure for our graph object. Here we can see that we have our graph processing. These are built-in algorithms. This is PageRank so this is the graph frame implementation, which we have used. You can tell by max iterations. The GraphX actually uses a tolerance rather than a set number of iterations. Here, this is our machine learning algorithm, which we ran 30 iterations of it to propagate labels throughout the nodes in our network. Now, before we're out of time, let's get back to our visualization and have a look at the final product. Briefly, here is the 2D implementation. Here you can get quite a different view of the network architecture. You can see we have our communities, which are detected by our machine learning algorithm, which is not actually based on the tags or similarity ratings that were provided. It's actually just based on the similarity creating an edge between two songs. If we look at our 3D representation, this actually looks a bit easier to see in full screen. So you can navigate around using the WASD keys and the arrow keys, and you can look using the mouse. Or alternatively, if you have a Google Cardboard headset, you can, on your phone, load the app and actually have a virtual reality experience here. So again, as with the other graph, you can see the node size is proportional to what we measure as the influence of the song. And the link width is also related to the similarity. If you hover over a song, you can see it displays the artist, the title, as well as a list of tags. These are the top tags sorted by value, so they are the most appropriate tags as selected by the users. So using these, you can sort of figure out what our machine learning algorithm has detected, and you can see where the colors and the tags differ, and it comes with some interesting results. So thank you. That has been a quick look at our submission for Assignment 2 CA675 Cloud Technologies.